Hello everyone, welcome to Unacademy. Let's crack it. Today it's a vector calculus part 5 and the vector calculus today vector integration we are going to discuss, a line integral. It's a fifth part. Already the 4 parts, there are 4 sessions we have completed in the part of vector calculus. It's a fifth session on the vector calculus. Yes, before moving into the vector calculus topic, yes, here coming to the Unacademy Compact, India's largest weekly competition for GATE and ESE. For the mechanical engineering, civil engineering, electrical engineering, electronics and communication, and computer science and IT departments are the eligible departments. Access your GATE preparation in 60 minutes. Challenging and original GATE questions curated by the best educators. Take it live to compete with the best, superfast and fun with the All India Live Leaderboard. Identify and improve your weak areas through the detailed video solutions. Use the referral code Moorthy36 to join into the Unacademy Compact. And 11th, already the 2 tests over, July 4th as well as 11th. And coming Sunday, 18th, you are going to have the next test. It starts at 11 AM and the test will be conducted for 60 minutes, 20 questions. And it's completely the original GATE questions, right? And if you secure the rank from 1 to 3, you can get the complimentary Unacademy Plus subscription for 1 year. And if you secure the rank from 4 to 10, 75% offer on the Unacademy Plus subscription for the teacher of your choice. Rank 11 to 50, 50% offer on the total subscription. Rank 51 to 100, 25% offer on the Unacademy Plus subscription for teacher of your choice. Winners can choose from 6 months, 12 months, or 18 months, or 24 months. Get an ESE Plus subscription. Here the terms and conditions are applied. Okay, the batch. So we are doing the complete batch course. So I'm handling complete engineering mathematics and mechanical engineering core subjects in this batch. Spark for GATE 2022, Web for GATE 2023. English batch completely for the mechanical engineering. Use the code Moorthy536. Use the code Moorthy536 to avail the benefits. Now the vector calculus. Today in the vector calculus portion we are going to discuss line integral. Integration of vector functions. Previously the divergence, gradient as well as curl of the vectors we have completed in the previous sessions. Now integration, line integral. An integral evaluated over the curvature C is called a line integral. Here the curvature evaluated over the line integral over the curvature here assumed as line integral. We call C as the path of the integration. Here it's a curvature C is the path of the particular integration. We assume every path of integration of a line integral to piecewise smooth consisting of finitely many small curves. What is meant by piecewise smooth? And if you take the cube, there are 8 edges are there, right? Is it clear? There are how many edges are there? Oh, sorry, 12 edges are there, right? So all these edges are considered as line integral or piecewise smooth finite elements. A line integral of a vector point function f vector of r vector over a curvature C. A line integral of a vector point function f vector of r vector over a curvature C, where r is the position vector of any point C. Now whenever we need to identify the line integral for the given vector function, so this is the formula, integral of. So this is the formula. Here it's integral over the curvature C. Integral over the curvature C. F vector is the given vector. dr vector, its position vector. Dr vector, its position vector. Position vector. Then how to conclude this vector part? I will explain it. Listen. If here coming to this second one, if f vector, the formula we have of it, so this will be the line integral formula. Now if f vector is equal to f1 I vector plus f2 j vector plus f3 k vector, and r vector is equal to xi vector plus yj vector plus zk vector, then dr vector is equal to dx I vector plus dy j vector plus dz k vector. So here r vector they are giving. What we need to do? So we need to differentiate the r vector in both LHS as well as RHS. R vector differentiation is dr. Then x differentiation dx, y differentiation dy, z differentiation dz. Now substitute the vector. It's a, for example I am giving it. It's an f vector, it's a r vector. Integral over the limit curvature c. Here it's c indicates the path of the integration. It may be an here c, where c indicates that. Okay. Where c path of the integration. It may be a straight line or parabola or ellipse, whatever it may be, it will be considered as path of the integration. Okay. Now, so coming to the f vector dot dr vector. Already the f vector, if you assume the f vector is equal to f1 I vector, we are substituting here f vector. f1 I vector plus f2 j vector plus f3 k vector dot dx I vector plus dy j vector plus dz k vector. It's equal to, now the I vector and I vector coefficients multiply. I vector dot I vector is equal to 1. f1 into dx, f1 dx plus j vector into j vector coefficient, f2 into dy, and j vector into j vector is equal to 1. So if you multiply the one directional vector with the other directional vector with the dot product, it's 0. The same thing already we have discussed. I vector dot I vector is equal to j vector dot j vector, it's equal to k vector dot k vector, it's equal to 1. And other than this process, completely 0. If I vector dot j vector or j vector dot k vector or k vector dot I vector, which all are 0. Only the same vectors multiplied, it's equal to 1, other vector 0. So as per this procedure, I vector dot I vector, we are getting the f1 dx. And if you multiply the next one, f1 I vector into dy j vector 0, f1 I vector into dz k vector 0. Likewise, only the corresponding vectors are multiplied together. Is it clear now? Now f1 dx plus f2 dy plus f3 dz. If the path of the integration c is closed curvature, we write the closed integral instead of n circle. The integral over the limit circle c by the n circle, right? Instead of the normal integration over the limit c, whenever the integration is closed one, right? It's a line integral formula. Okay, I will show you the one more one. What the line integral? Line integral over the limit c, f vector dot dr vector is a scalar point function. Why it is scalar point function? While multiplying the f vector dot dr vector, there is no vector symbol, right? Then it is called as scalar point function. Two other types of line integrals are also considered. Now it's dot product. If it is cross product and integral over the limit scalar into dr are vector. So only the vector dot position vector is scalar, the remaining two are the vector functions. Listen, now I will show you the one example problem regarding this line integral. After completing a few example problem, we are moving to the previous question, right? Example, if f vector is equal to 3xy I vector minus y square j vector, evaluate integral over the limit c f vector dot dr vector, where c is the arc of the parabola, y is equal to 2x square from 0, 0 to 1, 2. 0, 0 to 1, 2. Now look at this condition. We know the formula. What will be the formula? Evaluate the line integral. So this is the line integral we need to identify. F vector, it's a f vector, they are giving the question itself. Dr vector, yes, it depends upon the position. Dr vector, directly we are considering the r vector. So we can consider that r vector is equal to xi vector plus yj vector. Why we are considering only 2? Up to the j vector only we are having in the f vector. So we can consider plus zk vector also, but while multiplying the zk vector it's 0. Then here c is the path of the integration. Path of the integration. That path is yes, path parabola. Path is parabola. Is it clear now? I will explain this example problem. From this example problem, we are going to discuss one previous year question. Okay, listen. Now, f vector is equal to 3xy I vector minus y square j vector, and r vector xi vector plus yj vector, where r is the position vector. At any point on y is equal to 2x square. Y is equal to 2x square. And now this is the path. So this is the path from point 0, 0 to 1, 2. 0, 0 to 1, 2. What it indicates? 0, 0 to 1, 2. What it indicates? And x varies from, x limit it varies from 0 to 1. Y limit it is varies from 0 to 2. Line integral is the single integral, right? Not a double integral. Here, line integral is the single integral. We can substitute either x limit or y limit. So what we are going to do? Either we are going to consider all the total function in terms of x variable, or it may be a y variable, right? Here y is equal to 2x square. So the y is replaced by x. Y variable is substituted in terms of x variable. So while substituting the y variable in terms of x variable, we are considering only the x limit. In case we are substituting x variable in terms of y variable, that means x is equal to root of 2y. Then we need to substitute y limits, right? Coming to the next one, dr vector is equal to dxi vector plus dyj vector. We can keep the d is at k vector also, but why we are not considering k vector? While multiplying with f vector, there is a no k vector in the f, so it's not necessary to write the z, right? Now, f vector dot dr vector is equal to 3xy I vector minus y square j vector dot dx I vector plus dy j vector. It's equal to 3xy dx minus y square dy. 3xy dy, so dx minus y square. Now what I am going to do? I am going to substitute in terms of the point. While multiplying these 2 points, so this is what I am getting, integral over the limit c, f vector dot dr vector is equal to 3xy dx minus y square into dy. Now the equation c is, we are aware of it. What we are doing? Y is equal to 2x square. Y is substituted in terms of x. Now the same dy is substituted in terms of dx. Now the differentiation of the equation both sides, dy y differentiation equal to dy, 2x square differentiation equal to 4x, again x differentiation dx. 2x square differentiation with respect to x, 4x, again x differentiation, it's dx, right? So instead of y we are substituting 2x square, instead of dy 4x into dx. Now limit, so we are considering the substitution in terms of x variable. So we need to consider the limit, x limit. Is it clear? Is it clear? So how we are taking this x limit? In case we are substituting with respect to the y variable, in terms of y variable, we need to consider the limit as y. But here x only, 0 to 1. X varies from 0 to 1. Now 3xy into dx. Here the y is substituted in terms of x. Now here y is equal to 2x square, replacement. Again here y square is equal to, it's a 4x, 2x square the whole square, 4 into x power 4. And dy, what about the substitution of dy? Again dy is equal to 4x into dx. I think it's not visible, right? Look at this condition, it's a 4x into dx. Okay, fine. Next one. Now 4x into dx, While multiplying this value, what we are getting here? Here itself we can complete, right? Now it's equal to integral over the limit 0 to 1 f vector dot dr vector. It's equal to integral of 0 to 1 3 into x square. It's a 6x cube minus, it's a 16x power 5, 16x power 5 into dx, right? So we need to integrate it. While integrating it, 6x power 4 divided by 4 minus 16x power 6 divided by 6. Now substitute the limit, it's 0 to 1. By substituting the limit, it's 0 to 1, 6 divided by 4 minus 16 divided by 6. What about the value? It's 3 divided by 2 minus, it's an 8 divided by 3. And if you take the LCM, what about the LCM? Yes, so this is the LCM. This is what we are doing. Minus 7 divided by 6. Minus 7 divided by 6 is the right answer. Guys, is it clear? Guys, in case you are having any doubt, immediately ping your doubt here. Is it okay? Okay, fine. Now I will explain one previous question based on this model, then you will get it easily. The one more question I will show you. Listen. Here, the previous question. In the previous question, they have mentioned the value of f as well as path. Here, what will be the path? Here, path is parabola. It's a curvature, right? Next one, path is the straight line. Yes, good evening, Ukas boy and Vivek Yadav. Nice to meet you guys in the live session. Yes, next one. If f vector is equal to 3x square plus 6y into I vector minus 14yz z vector plus 20x z square into k vector. Evaluate the line integral. Integral over the curvature C f vector dot dr vector, where C is the straight line. So they are giving C is the straight line, not the in the previous problem. Look at this condition. While comparing the previous question, you will get some clarification. Here, where C is the arc, where here C is the arc of parabola, but here where C is the straight line. Previous problem parabola, here it's straight line. So in the parabola, y is equal to 2x square. They have mentioned the equation for the parabola, the question itself. Here only they are giving the end points of the line. So if you know the end points of the line, so we can identify the straight line equation directly by using the formula. Now f vector we are writing r vector. So we need to write r vector is equal to xi vector plus yj vector plus zk vector. Zk vector, is it right? Now f vector dot dr vector is equal to, while multiplying the f vector, 3x square plus 6y into I vector minus 14yz into z vector plus 20x z square into k vector dot dx I vector plus dyj vector plus dz k vector. 3x square plus 6y into dx minus 14yz into dy plus 20x z square. So I vector dot I vector, j vector dot j vector coefficient, k vector dot k vector coefficient. Now we have identified the f vector dot dr vector, but we require the value of C, equation for C. Line, it's a 3-dimensional, right? From this point itself we can conclude, the point itself we can conclude x varies from 0 to 1, y also varies from 0 to 1, z also varies from, it's a 0 to 1. But line integral, we need to substitute the equation in terms of any one of the variable, not both variables, right? So we need to substitute the equation with any one of the variable here. The equation of line joining 0, 0 to 1, 1, 1 is, it's a straight line equation. Straight line equation, x minus x1 divided by x2 minus x1, it's equal to y minus y1 divided by y2 minus y1, it's equal to z minus z1 divided by z2 minus z1. Now substitute the point. x1 is equal to 0, x2 is equal to 1 minus x1 0 is equal to y minus y1 is equal to 0, y2 1 minus 0, z minus z1 0, z2 is equal to 1, 1 minus 0. Now, so we can write x, y, z. Here what I am going to take, all the variables I am going to take in terms of one variable. Either we can do here for x, y, z, I am going to substitute the letter t. We can substitute the common letter t like this, or we can take the direct value, or we can keep x is equal to y and z is equal to y. In terms of y variable we can substitute, or y is equal to x, z is equal to x, right? In terms of all the variables in terms of y, all the variables in terms of x, or all the variables in terms of z. So we can use any one of the substitution here. Here what I am doing, so for all the letters I am going to take the common substitution t. It's not necessary to take t. You can substitute x in terms of y, x or z variable also. Here I am taking the common variable t. Let's say t. Now, so this is the equation for the straight line. So this is the equation for the straight line. Now the differentiation, x differentiation, x is equal to t, right? X is equal to t, y is equal to t, z is equal to t. And if you differentiate it, dx is equal to, dy is equal to, dz is equal to t. So we have to differentiate it on both sides. So this is what we are getting, right? Now t varies from, if x is equal to 0, t is equal to 0. If x is equal to 1, t is equal to 1. Likewise, if y is equal to 0, if y is equal to 0, t is equal to 0. If y is equal to 1, t is equal to 1. Here t also varies from, here t also varies from, here t also varies from, it's a 0 to 1, right? And if you substitute any one of the variable limits into the equation, we are getting the same value. It varies from 0 to 1. Is it clear now? Okay, next one, I will expand it. Yes. Now, t varies from 0 to 1 at any point. What I am going to substitute? Instead of x equal to t, y is equal to t. Therefore, it's t square. Here also t into t. Here t dot t. Here t dot t square. And if you substitute all this value, 3t square plus 60 into dt, x, y is at all equal to t. X square plus 6y, so 60, and we are getting minus 14t square into dt plus 20t cube into dt. Now integrate it. So we need to integrate it with respect to t. Yes, Srinivas Pramal sir, welcome. And if you integrate the function with respect to t, 3t square plus 60 minus 14t square plus 20t cube into dt, right? It's 20t cube minus 11t square plus 60. Okay, now substitute this point. 3t square 60. Now we need to simplify the equation. It's 20t cube, it's 11 plus plus 3 minus 14 minus 11t square plus 60. If you integrate it, 20 divided by t power 20 t power 4 divided by 4, 11 t cube divided by 3, 6t square divided by 2. Now substitute the limit 0 to 1. If you substitute the limit 0 to 1, it's 13 divided by 3. While doing the simplification, we are getting it's 13 divided by 3. So this is the equation, right? Now based on this concept, I will give you the one previous year question. Then you will get some clarification on this method. It's mechanical engineering 2005 2-mark question. It's line integral. Instead of f vector, they are giving here v vector. The line integral v vector dot dr vector for the origin to b, from origin. So what they are giving, the equation is from origin to origin is 0, 0, 0. Already we have identified the straight line equation for the point from origin to point P, that means 1 comma 1 comma 1. Straight line equation for, now I am giving it, listen. So we need to identify its value. So we can take line integral C v vector dot dr vector. What about the v vector? We know that v vector is equal to the given one, 2xyz I vector, 2xyz I vector, x square z j vector plus x square z j vector plus x square y k vector plus x square y k vector dot dr vector dx I vector plus dy j vector plus dz k vector, right? Now multiply this value. If you multiply the value, 2xy integral over the limit c 2xyz I vector dot I vector. What about the I vector dot I vector? It's 1. I vector dot I vector, it's equal to 1. Okay. Plus into dx plus x square z into dy plus x square y into dz, right? Now the straight line equation, for C, the points are 0, 0, 0 origin to point P, 1, 1, 1. Now the straight line equation, we know that x minus x1 divided by x2 minus x1 is equal to y minus y1 divided by y2 minus y1 is equal to z minus z1 divided by z2 minus z1. Now substitute this equation. Now it's x minus 0 divided by 1 minus 0, y minus 0 divided by 1 minus 0, z minus 0 divided by 1 minus 0. Let's say x is equal to y is equal to z. Now let's say it's equal to t. Let x is equal to y is equal to z is equal to t. Now differentiate it on both sides. dx is equal to dy is equal to dz is equal to dt. What about the variation of the t? X varies from here. X varies from, it's a 0 to 1. Y varies from 0 to 1. Z varies from 0 to 1. Therefore, t also varies from 0 to 1. Now substitute this method, and if you substitute the integration, 2xyz, now the integral over the limit, now it's a c v vector dot dr vector, it's equal to 0 to 1 2xyz, that is 2t cube into dt plus z square t, it's t cube, it's equal to t cube. Next one, is it clear now? Okay, now the next one, again z square was equal to again t cube here into dt into dt. While integrating it, now add all these values. What will be the value? It's 4t cube. 4t cube integral, it's a 0 to 1 dt. While integrating it, it's 4t cube, sorry, 4t power 4 divided by 4, it's 0 to 1, 0 to 1. And if you substitute the value, it's 1 minus 0, it's equal to 1. And solution for this question is equal to 1. It's option A. Is it clear? Okay, so these are all the important concepts in the vector calculus. Still many more concepts are there. So all the concepts will be discussed in the Plus course. So try to take the Unacademy Plus subscription to have the complete benefit, right? And the next session tomorrow 6 p.m. onwards we are going to start the complex variable. Okay, until bye from Sathyamoorthy.